Alrighty. So today we're going to learn about linear functions and how we can tell whether a function is linear or non-linear. So we're going to learn how to identify linear functions using graphs, and tables, and equations. We're going to graph linear functions with discrete and continuous data. And we're going to do some real-life problems to fit data. All right, so what is a linear equation? A linear equation in two variables, x and y, is an equation that can be written in the form y equals mx plus b. So that's a form that we're going to be looking for. Y equals mx plus b, where m and b are constants. And that means that they're just numbers that don't change. So m would just be a number and b would just be a number. So like y equals 3x plus 2, that would be a linear function. The graph of a linear function is a line. A linear function is a function whose graph is a non-vertical line. Non-vertical because a vertical line would not be a function. It's still a line, it's just not a function. A linear function has a constant rate of change. We call it slope. That's the constant rate of change. And a nonlinear function does not have a constant rate of change, so its graph is not a line. Okay, so does the graph represent a linear or a nonlinear function? Well, on A, is this graph a straight line? No, so this is nonlinear. But it is a function. If you imagine the vertical line test, there is no vertical line that will touch this graph at 2 points at the same time. So it is a function, it's just nonlinear. Part B, that's a linear function. The graph is a line. Boom, that's all you got to do. With a graph, you're just, if it's a straight line, it's linear. 6 seconds of bell is going to ring. And if it's not just a straight line, then it's not linear. All right, so tables. Does the table represent a linear or a nonlinear function? Okay, so on a table, to decide if it's a function, we're going to see if we have a constant rate of change. If the x value is going up by the same amount each time, then our y value should be going up by the same amount each time also. That would be linear, constant rate of change. So our x value is going up by 3 each time. So what's happening to our y value? It's going down 6, and then down 6, and then down 6. So it's changing by the same amount each time. That's a constant rate of change. So we have a linear function. For B here, our x value is increasing by 2 each time. What's our y value doing? From 2 to 9, that's up 7. From 9 to 20, that's up 11. From 20 to 35, that's up 15. So that's not a constant rate of change. So this is a non-linear function. All right, go ahead and pause and answer these and see if you get the right answers. See, the 1 is a line, so it's linear. 2 is not just one line. So we have a different rate of change over here than we do over there. This is linear because we have a constant rate of change. This one is nonlinear because it doesn't change at the same rate. Which of these equations represent linear functions? Well, we know that it has to fit the format y equals m times x plus b, where m and b are going to be constants. So let's see. For this first one, y equals 3.8. We could write that as y equals 0 times x plus 3.8. So that is a linear function. Y equals square root of x. We cannot write that as y equals a number times x plus b because it has square root of x. So this is non-linear. Let's see, y equals 3 to the x. X is in the exponent, so that's going to make this one non-linear. If it has something happening to the x, like a square root or an exponent, then it's non-linear. If x is in the denominator, that's non-linear. This one, y equals 6 times x minus 1. We can distribute the 6, and that would give us y equals 6x minus 6. And then we're in the y equals mx plus b format. So this one is linear. And then this last one, x squared minus y. We have an x squared, so that tells us it's non-linear. So we had, let me put the linears, I'll circle the linear ones in red. Those two are linear, the rest of them are non-linear. All right, so check these out. What do you think? There you go. We got a x squared over here. That's non-linear. The other two can be written as y equals mx plus b, so those two are linear. Number 7, non-linear because it has x squared. Concept summary. So a linear function has a constant rate of change. In an equation, it needs to be in the y equals mx plus b format. You need to be able to put it in that format. The graph should look like a line. And then by looking at a table or a mapping diagram, you should be able to tell if your y value is changing at a constant rate. Okay, so now we're going to talk about graphing linear functions and about discrete versus continuous domains. The solution of a linear equation in 2 variables is an ordered pair. Ordered pairs are in the format x comma y. Then that makes the equation true. The value for x and the value for y, when you plug them in for the equation will be true. The graph of a linear equation in 2 variables is the set of all the points in that format that represent all the solutions to the equation. Sometimes points are distinct. Sometimes the points are all connected. If they're distinct, then that's discrete. A discrete domain is a set of input values that consists of only certain numbers. So like the integers from 1 to 5, this is called a discrete domain. This is the kind of function where 1.5 would not be allowed as an input. Like, for example, how many tickets you could buy. You could buy 1 ticket, you could buy 0 tickets, so 0 would be part of the domain, but you can't buy a half a ticket or 1.5 tickets. So those are discrete domain kind of things. A continuous domain is a set of input values that's all the numbers in an interval. So all the numbers from 1 to 5. 1.5 would work, 1.1 would work. So continuous is where all the values in an interval are possible input values. Discrete is when only certain values are input values. Okay, so we have a linear function y equals 15.95x. So that represents the cost y in dollars of x tickets for a museum. Each customer can buy a maximum of 4 tickets. Find the domain of the function. Is the domain discrete or continuous? Okay, so the domain is the input. So what are the possible values for x? How many tickets can we buy? Is it okay if we buy 0 tickets? Yes, it's okay if I choose to buy 0 tickets. So 0 is in the domain. Can I buy 1 ticket? Of course. 2 tickets? Yes. 3 tickets? Yes, I can buy 3 tickets. 4 tickets is the most I can buy. And I can't buy part of a ticket. I can't buy half of a ticket or 1.2 tickets or anything like that. So only whole number values of tickets are possible. So this is a discrete domain. The domain is discrete because only certain values, you can't buy half of a ticket. And now we're going to graph the function using its domain. So I will put some numbers on my graph. Well, let's figure this out. I'm going to make an XY chart first. My X values are going to be 0, 1, 2, 3, and 4. And now to find Y, I just do Y equals 15.95 times X. So 0 times 15.95 would be 0. 1 times 15.95 would be 15.95. 2 times 15.95. Now I'm going to get a calculator. 2 times 15.95 is 3190. Go back. Three times 1595 is 4785. And 4 times 15.95. Try that again. 4 times 15.95 is 6380. So now I need to set up my graph. So I can go, let's see, 0, 1, 2, 3, 4. These are my possible X values. The Y values range from 0 to more than 60. So if I go 10, 20, 30, 40, 50, 60, that should work. So 10, 20, 30, 40, 50, 60, 70. Okay, so now I'm going to start plotting these points because it's a discrete domain, so I'm only going to have 1, 2, 3, 4. There's only 5 possible input values, so there's going to be 5 output values, and those will be the only 5 points that we graph. Okay, so 0, 0. Then we've got 1, 15.95, so that's about here. 2 and 3190. So 2, 3190, that's about here. 3 and 4785. So 3 and 4785, that's a little bit below 50. And then 4, 6380. So 4 and 6380, that would be about there. And you can kind of see that, that the points all line up. And this is a situation where we would not draw a line through all of them because the line doesn't really exist in between 0 and 1 because we can't buy half of a ticket or a part of a ticket. We can only buy whole numbers. So we only show the graph at whole numbers. That's what the discrete domain is all about. All right, then we've got this linear function. M equals 50 minus 9D. And M represents the amount of money you have left after buying D DVDs. So the domain of the function is going to be the possible input values. And it looks like you can buy 0 DVDs. You can buy 1 or 2 or 3 or 4 or 5 DVDs. But if you tried to buy 6 DVDs, that would cost too much money. 6 DVDs would cost $54, and you only have $50 to start off with. So the range is going to be, well, this is, first of all, it's a discrete domain because you can't buy 1.5 CDs or DVDs, sorry. So that's a discrete domain. Then you just figure out what are the possible numbers of DVDs you could buy. You could buy 0, you can buy 1, 2, 3, 4, or you can buy 5. And So then you're going to plug those in each one, and you're going to find the corresponding y value, and then you're going to plot those points.